Day 133, Honors Physics, Electrostatics, homework problem number 28. This is not a point particle problem. Even though there is a point particle involved, the 6.4 microcoulomb charge, it's not an arrangement of a bunch of point particles on the vertices of a triangle or a square. It's a point particle that's being accelerated. So this is not going to be using those four equations from the previous problem, problem 26. This is a classic parallel plate. So basically, if it's not a point particle problem, it's pretty much going to be a parallel plate problem. And I have these drawn vertical plates, so the particle will accelerate to the right. You could have them from top to bottom, ignoring gravity, where the particle would accelerate down or up. It doesn't really tell you which way it's accelerating. But I do know it's accelerating from the positive to the negative once I've drawn it like this. We're ignoring gravity. It doesn't look like we might have to ignore that, but we do. I'll show you that in a few minutes here. The bottom line is this particle will have a force due to the field. I could draw the field. The field would look like this. I don't need to draw the field here, but it's always from positive to negative. And the particle, a positive particle here, will accelerate to the right, and they're looking for the acceleration here. Well, bottom line is, you look at the equation sheet that we have. One of the most basic equations we have, a definition of electric field strength, E equals F over Q. Bottom line is, you can calculate the force on this particle because they give you E in standard units, volts per meter. So F will be EQ. They give you Q and E. They give you both of these. You'll plug those in and get F. F will be in newtons because everything comes out in standard form. If you plug in standard form, you want to convert the charge from micro to regular coulombs, so it'll be 6.4 times 10 to the negative 6th coulombs. That's what you'll plug in for the charge. And the E field is 125 volts. That's just plugged it in straight like it is. That'll give you the force in newtons. And then you just use F net equals MA. This is going back a while now. F net equals MA. And that force that you've calculated in part 1 here will be the net force, the only force acting because we're ignoring gravity here. And we have the mass of the particle. Put the mass of the particle in kilograms, not micrograms. You got to convert from micrograms to kilograms. So you'll have those two and just calculate A.